Mr. Scott here, and you're going to be watching a video on energy. More specifically, what energy is and how energy is transferred from object to object. Energy is the ability to do work, or the ability to create change in an object. In our unit on energy, we're going to refer to it in three ways. First, energy as a function of motion. Second, energy as a function of position. And finally, energy as radiation.
What do we mean when we talk about the energy in a candy bar? Or conserving energy? Or finding alternative energy sources? What exactly is energy? Energy is a property used to describe a wide variety of things, from the tiniest particles to the most complex systems. But unlike physical properties, such as color, length, or temperature, it's better understood by what it can do than how it looks or feels. The standard definition of energy is the ability to do work. In other words, it's the ability to create some sort of change in an object, whether it's the object's location or the motion of its atoms. All objects store energy, but they differ in the amount and forms of energy they carry. For example, chemical energy is stored in the bonds that hold molecules together. Potential energy can be stored in an object's position, like this apple hanging from a tree. And when the apple falls to the ground, that potential is transformed into kinetic energy, or the energy of motion. Not only does energy come in many forms, but we can also convert it from one form to another. For example, we make use of the chemical energy stored in fuels like oil and coal by burning them. When we do so, we convert their chemical energy into thermal energy, or heat, to warm our homes. Or we can use fuels to produce electricity, the energy carried by electrons moving through a wire. So if we can convert energy from one form to another, why are people so concerned about conserving it? The fact is, not all energy forms are equally useful, and not all conversions are easy to do or equally efficient. Take electrical energy, for example. We use it to power all kinds of technological devices. However, as the electricity drives computer processors and lights up TV screens, it's transformed into other, less useful forms of energy, especially heat and light. That energy isn't lost, it still exists, but once released into the surrounding environment, this relatively small amount of heat and light can't be recaptured and converted back into electrical energy. And so, whether it's fossil fuels today or large-scale alternatives in the future, we'll continue to need new energy sources if we want to keep our high-tech, electrified world running.
Alright then, so your key concepts are: first, energy is the ability to do work. Energy is the ability to create change. Kinetic energy has to do with energy and motion. Potential energy is energy related to position, and energy is converted from one form to another. Not all forms of energy are useful, and an energy is not lost, just spread out.